Hi, this is Mrs. Robel. This is part 3 of the Standards and Measurements unit. And today we're going to talk about standard units of measurement, and we're going to use those units for what we call dimensional analysis. Now, a group of scientists have gotten together and they decided that they wanted to standardize units because you want to have a certain amount of mass or volume when you're doing a chemistry reaction. And you want to be able to duplicate that around the world. And the only way that they could duplicate that is by standardizing the units. So you'll notice that there's some base units that typically are used in science. These are the metric equivalents. Some of them may look familiar, some may not look familiar. Obviously, time is seconds, length is meters, mass is kilograms. And actually, I wanted to show you, this is really a great instrument that you can use in your kitchen. And I actually use this when I'm doing baking. So sometimes I have to mass my flour or my salt or my yeast, depending on what I'm using. And it's a really great way to measure out grams. Kilograms are more effective in the chemistry lab, especially when you're doing large-scale reactions. So don't be surprised if you may have to do some calculations in kilograms. Now for temperature, you notice that it's Kelvin and it's not Celsius. When we do gas laws, we're definitely going to convert our units to Kelvin because Kelvin is a really good temperature scale to use for gas calculations. But for now, you probably will see more calculations using Celsius. For amount of substance, you may or may not have heard of the mole. Now, when we do stoichiometry, you're going to use moles all the time. It's a very good unit for figuring out how much do you have of a specific substance. It may be atoms, it may be molecules, it may be formula units. And we'll talk about that more when we get to that section. Then, of course, there's electric current, which is an ampere. You'll see that in physics, along with luminous intensity, or candela. Those I don't think you have to worry about as much in chemistry. Okay, so setting the standards, as I said, there were a group of scientists that got together and they decided to standardize the measurements in order to duplicate experiments around the world. So they came up with the kilogram, and the kilogram is essentially a combination of platinum and iridium, and it's actually in a vault in Paris, so they can bring out that mass and eventually weigh it and compare it with what they know is to be the kilogram. And for distance, the interesting thing is with meters, they don't actually have a yardstick that gives them the exact meter length. They use light. So they know exactly how long they need to time the distance that light travels. And notice that it's a fraction of a second, essentially a fraction of the speed of light. Okay, so here's volume. Now, volume can actually be measured out in many different ways, and the one that's probably most familiar to you will be the graduated cylinder. Notice that the liter is essentially a volume of a cubed decimeter of water at 4 degrees C. Now, you haven't taken my conceptual chemistry for obvious reasons, but water is actually its densest at 4 degrees C, and that's why they chose that temperature. Volumetric flask is another way to measure out liquids. I am more likely to use a volumetric flask, especially when I am creating some of the solutions that you need for chemistry. And the nice thing with the volumetric flask is it has this little line at the top of the cylinder or the flask, and I know exactly where to stop filling the liquid, and that will give me exactly the milliliters that I need. For a burette, when you take advanced or AP chemistry, if you have to do an acid-base titration, typically use a burette, and it has a little stopcock here. So it's a little switch that you open up to let the water or liquid flow and then you can stop it to measure exactly the volume of your substance. Pipette, we won't be necessarily measuring volume with the pipette. That's probably something that's more familiar with biology. But if you're using very small volumes, sometimes a pipette is very useful to do. However, in chemistry, we will use a syringe. When you get to gas laws, you're going to find that we're measuring air using syringe. It's very effective for determining the volume of a gas, and that's the advantage to using that. Now, hopefully you remember that 1,000 milliliters equals 1 liter. By the end of this course, you'll know exactly that. Notice that cube centimeter can replace milliliter. So in order to determine volume, we actually can look at the length of a container and then cube it and essentially get the volume. And then lastly, 1 liter equals 10 to the 6th microliters. Now that's a unit that probably would be on the very small scale, but it is a useful unit to know, especially if you're going to be doing biological reactions. Oh, and you know what? Before I forget, I trotted these out from my cabinet. These are some really cool graduated cylinders that my husband had bought when he was looking at making sauces. And the nice thing is it has ounces on one side and then it has milliliters on the other. And they're so adorable looking. Look at how tiny these things are. But when you're making sauces and you're measuring volume of a liquid, they're actually very helpful to use. Okay, now you might have noticed that there were certain units that were left off on that standardized unit sheet that I showed you. And the reason why is not all quantities can be measured with the base units. So what does that mean? Well, it means that you can actually take a combination of base units and create a derived unit. Now, some of those derived units are density, which we've done in the past science classes. I'm sure you've talked about it in other classes. Notice that volume was not on that original slide that I first talked about, and also area. So these 3 units are actually not something that you can measure with the base units. You have to derive them. Okay, here we go. Now that we have standardized units, what do we do with them? The important thing is that in chemistry, we are going to get very good at this. It's called unit analysis, or more familiar to me, dimensional analysis. Now, you've done this in the past, but you didn't know that you were doing this. Essentially what you're going to do is you're going to take 2 units, and these 2 units, you're going to combine them into a fraction, and they essentially become your conversion factor. And the nice thing about the conversion factor is you can manipulate measurements from one conversion to another, and this will make more sense in a minute. Now here we have the density of a substance A, and notice that the density of the substance is essentially 3.14 grams per milliliter. So we need that information for the next part here. They want us to figure out what is the mass of 16 milliliters. So what I'm going to do is I'm essentially going to take the 16 milliliters and I'm going to multiply it by this conversion factor. So I'm going to multiply it by 3.14 grams per milliliter. Now, there are no naked numbers in chemistry. Notice that you have to put units next to your number. If you don't, I will take points off when you're doing your quiz, because the advantage to this is essentially you cancel out the units and you're left with grams. So I'm not going to do that calculation for you. You can do that yourself, but don't be surprised if you see that on the video assessment. Now here's another example of dimensional analysis. They essentially want us to convert 96.4 grams to volume. So I'm going to take 96.4. Now my question is, do I want to multiply or divide by 3.14 grams per milliliter? Remember, I want to cancel out grams. Yes, I want to divide. Okay, so I'm going to take the 96.4 and I'm going to divide it by 3.14 grams per milliliter. And the nice thing about it is that the grams cancel out. We're left with milliliters, and the milliliters actually go on top. And like I said, I'm not going to calculate the value for you. You can do that yourself. Okay, here we go. So here's some more examples of dimensional analysis. And when you're looking at dimensional analysis, the first thing you want to do is you want to create a roadmap. Now notice that they want you to convert meters to inches, but there has to be an in-between sometimes. So we can't necessarily go straight from meters to inches, and we want to use conversion factors. So we have 100 centimeters per meter. By the way, I'm not going to give you that conversion factor. You should know it. And you know, over time, doing these type of calculations, you'll remember it, no problem. I may or may not give you the conversion factor of centimeters to inches, okay? Now, when you're doing a conversion factor or dimensional analysis, always remember that the units you're trying to cancel, for your conversion factor, you want to put it on the bottom. Notice that the units that you do want is on the top. Now, like I said, you have to essentially go from meters to centimeters to inches, so you have a second conversion factor. And notice that the units I want to cancel out, I put on the bottom. The units that I want stays on the top, okay? And notice that there are no naked numbers, that each set of conversion factors has its units, so we cancel out and we're left with inches. Now guess what? You still have to look at significant figures. So the answer has to be rounded to 980 because there are only 2 significant figures in 25. So yes, you have to keep that in mind when you're doing these type of calculations. Okay, here's another example. So they essentially want you to convert 454 milligrams to kilograms. So you need to have a roadmap. So you want to go from milligrams. Now, I'll tell you right now, you can't go essentially from milligrams to kilograms. You're going to go from milligrams to grams, and then after grams, you're going to go to kilograms. Now, in order to go from milligrams to grams, you need to know, and this is something that you're not going to get a conversion factor for, 1,000 milligrams equals 1 gram. Now going from grams to kilograms, you need to know that 1,000 grams equals 1 kilogram. Okay, now with these conversion factors, I'm essentially going to take that 454 milligrams, and how many, sorry, my M doesn't look too good there. How many significant figures am I starting with? Yes, 3, okay. Now I have milligrams, so I want to make sure that my conversion factor has milligrams on the bottom, so I'm going to put 1,000 milligrams on the bottom, and I'm going to put 1 gram on top. Now I want to get rid of grams, so I'm going to put 1,000 grams on the bottom and 1 kilogram on top. Now the nice thing is I have no naked numbers. Milligrams cancel out, grams cancel out, and I'm left with kilograms. And I will let you calculate the value for that. Okay. Sorry, I'm just going to fast forward this. Okay, skip that next one. All right, so I have a series of 3 problems that I want you to do for homework. And let me give you some conversion factors because you're going to need them in order to do these calculations. So 1 slug, equals 14.54, I'm sorry, 59 kilograms. And 1 liter equals 10 deciliters. Okay, so don't be surprised if I ask you for a couple of these problems on your video assessment.